All right. Hello, guys. My name is Tomek. We are here. The three of us are here from FluffyLabs. And let me quickly tell you about what we are doing regarding to Jam. So first, who are we? These guys over here and myself and Sebastian, who is not here, we are working on the Jam implementation in TypeScript. Not everyone is working full-time on this, although most of us is. And we also work on some Jam-related tooling, and for this we also have like a part-time support of these guys at the bottom. So our Jam implementation is called Typeberry. It's mostly written in TypeScript. Mostly, I mean like 95% right now. We have some stuff that is kind of offloaded to Rust. We are experimenting a little bit with assembly script, which is it says on the website, it's a subset of TypeScript. So this is why we started exploring this idea, because we were thinking that we maybe can argue that it's still TypeScript if we write an assembly script. But the cool thing about assembly script is that it compiles to WASM. In reality, it's pretty much like a one-to-one mapping from WASM to like something that pretends to be a TypeScript. And the reason for this was because we knew that some parts might require some more performance optimizations later, so we were thinking, okay, we're going to compile that to WASM, and then we will run that WASM blob as part of our client as well. We are hoping to support browsers. Maybe if we choose the light client path, that will be an interesting option to have the client be running in a browser, and obviously browsers can support JavaScript natively as well as WASM natively. So we are roughly M1 compliant. We are missing one thing from being fully M1 compliant. We started working on some parts from WASM 2. And as I said, we haven't decided yet if we are going to follow like the light client path or the non-PVM validating node path or the regular path. It depends on how much resources we can put into this and how fast our client is going to be. One thing that I forgot to mention on the team side is that I'm the only guy there who has prior blockchain experience, so most of the team members don't, and it's also a journey for all of us to kind of explore these blockchain-related ideas. Like we all know TypeScript, but we don't know how blockchains work. So we are kind of learning as we go how to build blockchains as well. Tooling, yeah. So you might have used some of these tools already. I don't want to show everything here. I will just show the last thing. So maybe I will just mention. One of the tools that we have is called Gray Paper Reader, and this is something that you've probably seen in all of the Matrix channels when people share links to particular parts of the Gray Paper. The other thing is PVM debugger. So you can load the PVM blob, and then you can disassemble it. You can see all of the PVM instructions, and you can actually run the blob as well and go instruction by instruction and see what happens. And the last thing that we've released yesterday is called Jumpstart. So let me just quickly show that to you. So the idea is to basically have one place where you can look for things among like Jam resources. So we are indexing the Gray Paper, obviously, and we are using the Matrix Archiver thing that Erin built to index both the history of both of the Matrix chats. We can support some other things as well, but you can look, I don't know, for Grandpa, let's say. You should see the results. This is the results coming from the Gray Paper. These are the results coming from Gray Paper Matrix channel. And if you, that's a new thing that they must have deployed like when we were here. Let's try it. Okay, yeah. So it loads basically a this matrix archiver, and you can see that particular message that mentions grandpa in the context of the whole history. Cool. Some more tooling. So we've been trying to build some other stuff as well, but we didn't put like enough love, I would say, for these tools. So one of the tools is a codec tool where you can put like a encoded blob, and it's going to decode it and give you like the blob header, whatever jump structure you want. We've been at the very beginning, we've been trying to build like a tree tool, so you can load a bunch of keys, load a bunch of values, and it's going to visualize how the Merkle tree should look like. And one more thing that I wanted to mention is kind of related to the gray paper reader, and it's the links check tool. It's on NPM, so you can just run it through npx. And what it does is, if you have links to the gray paper reader in your code base, it will generate a particular JSON file, which contains kind of back references that you can later on load in the gray paper tool. Let me show you exactly what I mean. So in our code base, we have a bunch of gray paper reader links, and these nodes that you see over there are generated from this file, this JSON file that I mentioned. During our CI process, we basically run the tool. We generate a JSON file, and it's available somewhere on the internet. And then you can load this file into the reader. I will show you how in a second. And when we read the gray paper, we basically see in which files this particular section of the gray paper is referenced. So if you want to do something like that yourself, I really invite you to do that. You have to go to the settings of the nodes, and you can add a new remote source with the JSON file that we generated. This is not going to be available for everyone. It's just like on your local computer, you will see these annotations. But I think it might be helpful for you guys. Yeah, and some ideas that I'm open to discuss. Obviously, I'm open to discuss any tooling ideas that you guys might have, and we can evaluate if that's something that we could build and would be helpful. Obviously, if you have any feedback on the existing tooling, we are happy to hear it. Some of the ideas that I have around the PVM debugger are maybe we could talk about having some sort of standardized PVM tracing, where instead of actually loading and running the program in the PVM debugger, you would just load a trace file, and then you could just go step by step through that trace file. Oh, yeah, sure.
I'm planning something like that.
Okay, you're planning something, like the tracing stuff.
Yes, exactly.
That's going to be awesome. Because the issue with the PVM debugger is that it's hard to support like all of the host calls, and we were thinking, how could we do that? Should we have like an RPC that would actually go to the node and read the state? But if we have the tracing, then you will be able to easily even load two traces alongside, and then we can tell you, hey, it differs in that place, and then you can go back and forward in the execution process and see exactly how the things were being changed. Some other idea that I was trying to explore sometime, but I kind of shelved that, but I still think it's something interesting, is compiling WebAssembly into PVM. So one of the ideas how that could be useful is, I mentioned assembly script earlier, and imagine if you could not only write the PVM services that Gav mentioned earlier in Rust and in the Jam SDK that the Parity team has put together, but rather we could try to build an SDK in assembly script, right? And then from the marketing point of view, you can say, well, you can write services in TypeScript for Jam. Obviously, they wouldn't be super performance efficient, but well, who cares? I'm curious how it's gonna be, how it could work. So I have a few ideas around this one, and I hope to talk to Jan as well how this could be done. One of the ideas is to go through WASM to C, and then from C to PVM, but this is going like up and down, which is not super efficient. And another thing might be going from like WebAssembly into LLVM IR into PVM from there. Yeah, so I already mentioned the assembly script Jam SDK, and the last thing is also something that I really think it might be important in the kind of long-term future. Is imagine that we have a bunch of clients implemented separately, went through all of the milestone 3 to milestone 5 steps. So each of these clients have a PVM recompiler, right? So we have a really super efficient environment that is able to run a sandbox code almost in a native speed. And each of the client has that, right? So there's many things that in all of these clients is going to be very common. Like, for instance, the RPC behavior should be exactly the same if you want to support that stack. But this is not a consensus critical code. So what if we could have a PVM-based plugin systems for the clients? We just agree on some sort of like a set of host calls that is available for all of the that all of the clients provide, and then the whole RPC could be just implemented as a plugin, as a PVM plugin, and exactly the same RPC is going to be running on all of these three clients. So instead of implementing this one thing, which is not consensus critical, which is not specified in the gray paper, 3 times by 3 independent teams, we just implement it once and we run it on all of the clients. So RPC is just one example, but I guess you can imagine that there might be many more things. You can build like an indexer that will be deployed and running alongside like every Jam node. So yeah, if you're curious to hear more about this, please find me later, let's talk. And yeah, I guess that's it. Any questions? Okay.
Not a question, but kudos on a great paper reader. That's been super helpful.
Sorry, say again, what? Kudos, okay.
Great paper reader. Thank you so much for that.
Yeah, it's Marcin and Sebastian, who's actually not here, but yeah, kudos to them. Okay.